comparing. Now what I would very much like to see you do, and I will tell you this at least 1,006 times in your mathematical careers, is I would very much like to see you draw or sketch out the problem. You don't have to be an artist to do this. This is just trying to give yourself a better way to look at the problem. For example, here is a problem. Let me see here. I want to find it. Mel is 6 years older. Change colors here. Mel is 6 years older. Mel is 6 years older than his brother Bob. Then bro Bob. Okay. Mel is 11 years old. How old is Bob? Question mark. Now, some of you right away look at this and know the answer, and that is all well and good, however I get here. Okay? Because you'll come across ones that you think you can do in your head and you shouldn't do in your head. What I just need for you to do is this. Just make a couple little boxes that represent Mel and Bob and their age. For example, here is Mel. Just a little bit of a box there. Now Mel is 6 years older than Bob. So if I draw a box to represent Bob, do you suppose Bob is going to be bigger than Mel or Bob is going to be shorter than Mel? If Mel is 6 years older, my box that shows Bob should be a little shorter because Mel is 6 years older, so he would be bigger. Okay, so right away, and when I look at the picture, okay, right away I can tell who's older, who's younger, right? I don't have to go back and read the problem and say, what did it say again? Okay, and what do we know? Mel is 6 years older, which means this. What's the difference in their ages? There you go, whoever said that, 6 years. Okay, there's 6 years there. No, he's 6 years older, so it'd be 6 years. Are you doing some twisted math there, maybe? 6 years older means you'd be 6 years older. What's that? If Mel is 11 years old, if Mel is 11 years, how old would Bob be? Now, obviously, if you said 17, that doesn't make a whole lot of sense, does it? Because Bob is obviously younger. Okay? I know, and here's kind of a backwards way to think about it. If you take Bob's age and add 6 to it, you're going to get Mel's age, right? And we know Mel is 11 years old. So what number, when you add 6 to it, is going to give you 11? You can probably do that in your head there. Alex?
5.
Exactly. Bob has to be 5 years old.
I thought you said 6.
What's that?
You said 6.
You're losing me. Wait.
11 minus 6 equals 6.
Wait, did I do something wrong? Or you
No.
okay. Maggie, did I say 5 years and write 6 or something? Did I do something wrong there?
I heard you guys say 6. Let's see.
Okay, it is 6 years. I think that's 6. But the thing is, and this one's not so bad, 5th graders, but eventually they're going to compare 3 different people, okay, and then you get confused in all the information that they give you. If you can sit down, look at it, and write it down, it just helps keep you organized and you know what's going on here. So anytime they give you, you know, a comparing about people, dates, I suppose you could do too, but especially with the people thing there, you know that it's something that you need to sketch a little picture for. The other one they do is they compare times or dates. When you compare dates, what do you think you're pretty much always going to do? In other words, here's a question. Let me see. How many years are there from? How many years from 1492, which was what? When Columbus sailed the ocean blue, to 1620. Anybody know what happened in 1620? Is that the Pilgrims?
Yeah.
Are you sure? Are you just saying that?
Yeah.
Or 16 something.
That's probably what it is. I'm not 100% sure. I'm not. If you were drawing the picture of that, here is your 1492. Here is your 1620, and you're looking for the difference. And anytime you're looking for the difference, what type of problem is that? Difference is the answer to a subtraction problem. 1620 minus 1492 is 128 years. 128 years. Or our last example here, the day begins at 8:10 and ends at 3:15. That's pretty close to ours. Your day begins at 8, did I say 15? 8:10 and ends at 3:15. Ends at 3:15. How long is the school day? Now, what's the one thing you have to be careful with time? We talked about this before. When you talk about time, Brooke, it's AM and PM, but also what? Well, it goes up to 12, but also what? What's the big thing, Maggie? Right. Unfortunately, whoever made our time didn't put 100 minutes in an hour or this or that. They put 60, which is kind of goofy because what's the best way, or how would you find how much time there is from 8:10 to 3:15? Anybody? There's more than one way to skin a cat there. We're going from 8:10 to 3:15. What would you do if this was your problem and you needed to find out how many hours, how many minutes that was? Ryan?
I'd subtract 8, 10 from 15.
All right. Well, here's the problem with that. That's all well and good, but as it is right there, it appears to me I'm subtracting a big number from a small number. How are you going to do that? There's a way to do that. Anybody know what you'd have to do? If you're doing it this way, Taylor, what would you do? Ryan? Huh?
The time with all 24 hours and numbers.
Yeah, do you know how you change 3:15 into a 24-hour clock thing? What would it be, do you know? I don't know if this is,
15.
right, you'd add 12 to it. This is actually 15:15. I don't know if that's the easiest way to do it. What are some of the rest of you? How else would you do this? What if you're going from 8:10 to 3:15? Madison, what would you do? You'd actually look at a clock? What if you don't have a clock available? Maggie?
But draw a clock at 8:10 and then 3:15 and then count 5, 10, 15.
All right, I think that's probably a viable thing. You could probably do that. Draw the clock and figure out at 3:15. Anybody else without drawing the clock? Sammy? Any suggestions? Ryan?
You count 9, 10, 11, 12.
Okay, I think Ryan's kind of got it.
Just add 5.
Here's what I would do. Take a look up here. The first thing I would do is I would say to myself, how many minutes, Madison, how many minutes would it take me to get to 9 o'clock? If I'm at 8:10, how many minutes would it take me to get to 9 o'clock? 50 minutes, right? So I know to get to 9 o'clock would take 50 minutes. So now I'm at 9 o'clock. And then how many hours to go from 9 o'clock to 3 o'clock? 9 o'clock to 10, 10 to 11, 11 to 12, 12 to 1, 1 o'clock to 2 o'clock, 2 o'clock to 3 o'clock is 6 hours and 50 minutes to get to 3 o'clock. But I want to go all the way past that to 3:15, which would mean I'd have to add what? How much farther do I have to go? Another 15 minutes. And there again, it gets a little strange because now I'm going to have 6 hours, 65 minutes. But you never say 65 minutes. You have to take an hour away from that. You're left with 5 minutes. So it would be 7 hours, 5 minutes. there's not really an easy, simple way to do this. You kind of have to pick. You could do the clock. If the clock works for you, that's good. You could do the 12-hour thing if that works for you too, because you'd get the same thing. Okay, you get your 5 minutes there, and then 15 from there is 7 to 5. Or if you could just think about it this way, going from one time to the next time to the next time. It's not an easy thing, again, mostly because our hour's not split into 100 minutes. It's not in a set of 10. So you use whatever way